Good afternoon, guys. Welcome to our Python lessons. In this lesson, we'll go on with a recursion, and we'll start with the examples of class structure. And after this course 8, lessons 8, there will be the last one, and I'm gonna finish this lesson series. So without wasting our time, I would like to start with our lessons. Okay, in this example, I would like to give an example of a recursion function. Here I define a function factorial here with parameter x, and at first I would like to make a comparison. If it equals to 1, so just return to 1, else return this value by decreasing the factorial number so as to reach number 2. So I call this function with parameter 5. So let's see what it is to be calculated. Okay, 120. I want to give another example here. Just this is a fake example. In fact, this erroneous example. Here I define factorial x once again, and return this value, and when we run this, computer will stuck and does not give any result, because maximum recursion depth exceeded message will be given. So just perform and see the result. Okay. It says that previous line, this is one, repeated 996 more times. So you have to restrict yourself using this structure. Let's go back once again. You have to use this comparison. Okay, let's go one more example with one more example. So I'd like to mention lists, sets example here. The sets are one of the data structures within Python. There are others, lists, tuples, sets, dictionaries. Here I define a set here, including these members, and another set here I define word set, and it has 3 elements, right? 3 members. So I say print 3 in num set. Okay, 3 will be printed here, and if 3 in num sets, it's going to be printed. And the result will be a logical one, of course, and this one also spam not in the word set. Of course, this is true. This is not true, because spam is included here. So after we run the code, we see that this is logical true. This is logically true, right? And actually this is true, but because of not expression, not negation, the logical result will be false. And let's go another one, demo 156. Okay, this is our set, letters, its name. If character A or letter A not in letters, okay, print 1, otherwise else print 2. Is there in fact? No. So 1 will be printed. So let's make it run and see. 1 will be printed. Okay. And what about the else, the other one? My new set is like this, and it's named nums, and I would like to print it nums once. Okay, and it is like this as expected. Okay, and I would like to show you add method here. By using this notation, any member can be included into, can be added into a set. So here it is added, -7 is added, and I would like to print once again nums included 7. Okay, 1 2 3 4 5 6 -7, and after that I here would like to show the function of remove method. So number 3 will be deleted from the set. Okay, after printing, we can see 3 is deleted from the set. So there is another example with sets, of course. Our set includes 4 members, such as this and this, this and that. Here there is a explanation here. There can be printed some members of a set in out of order manner. So when we run this, we expect that as if it is printed in order manners. No, for sets there is no such a rule because of memory allocation. While printing procedures, members can be replaced with each other, A, C, D, B, like this. In a set concept, the uniqueness of members are important. Their order is not important, so that's why it's not printed in order manner. Okay, I would like to show the function of add method here in the lower line. I would like to add character Z at this line. So after adding, I would like to print the nums sets once again, and just as you see, Z, C, B, A, D will be printed. And just I wonder if what is the length of this new num set. So there is a keyword for that. Length can be used in order to find the length of this num set. So just as we count 1 2 3 4 5, the length of this num set is 5. It's 5 members long. So in our demo of 159, I here declare 2 sets, and I would like to show you set operations here. As long as far as I remember in my high school years, we could use Venn diagrams in order to visualize the operations that can be made by using sets. In fact, this is very similar to that one. Just I can remind you the case. This operator stands for or summation, just I can say, and union is proper name, sorry, and this with ampersand, that means difference, intersection will be calculated by using this one. There are 2 operands in fact, and by using this minus sign, difference of the sets, different sets can be calculated, and at this one difference with the reverse order. I mean, the first set will be deducted, will be subtracted from the first one, sorry, and there is a very sympathetic character here. It is actually exponential sign in some languages. It is called a symmetric difference, in fact. First, symmetric difference second. So let's see their functions one by one. Just I would like to mention the common elements 4, 5, and 6. And yes, 4, 5, and 6 is common in both sets. I mean the three of sets of first set and the three of members of the second set is common. It's common. Okay, let's make it run and see the result right away. This means that print command will print the union of two different sets. I mean union of the first set and the second set. So 1, 2, 3, 4, 5, 6, 7, 8, 9 will be printed. Just as I said before, uniqueness is the mentality in sets concept. There can be mentioned more than one same member, but while it is considered as a set member, the repetition will be omit, will be disregard, and it will be printed only once. Okay, just here we cannot see the repetition for 4, 5, 6. And what about the second command, second feature? First intersection B second. So that means we are looking for the common elements. Just I said before, 4, 5, and 6 are common in both sets. So let's see the other feature. First minus second. That means it's going to be a simple deduction. In fact, just look at the first set in this list, and it's going to be deducted the remaining part, right? This one, and let's see the result. Okay, 1, 2, 3 will be remaining. Okay, and what about the reverse deduction? Deduction in the reverse way, reverse direction. So 9, 7, 8 will be printed, and the other one will be skipped or will be omitted. And this is a symmetric difference, just as we mentioned, as a component exponential sign. So just look, 1, 2, 3 and 7, 8, 9 will be remaining, and the symmetric ones or the common ones will be deducted. Okay, let's go further with our here I can start with class structure, and I can give examples here. Here I would like to mention init method in class operations. Sorry about that. I here declare a class named dog, as it is inherited from Java root. Class name will be starting with uppercase. So our class is dog, and let's define an function here, init function, init method. So just look here. So I here say itself, but you can try it in your own language. Just you could use A, B, or in my native language, candy. Candy, for example, I can say candy. That means own, its own. That means, and there are two parameters, name and color. So I have to mention this. And self.name will be name. Okay. Self.color will be color. So I here define another function here, bark, and it accepts the parameter self once again, and I'd like to get it printed woof. Woof stands for howling barking in fact. It's another word to be used for barking, and okay, that's all. These are all within the block of class dog. So here I create an object of class dog here, and I assign it our variable Fido. Okay, dog class, when it is called or when it is objected, it created an object. Fido and Brown parameters will be carried out, will be accepted. So just here I would like to print it Fido name, Fido, by giving name, and what it is expected to print out name, in fact, name. Okay, and here this is an instance of Fido with a bark method. That is the notation like this. So I'd like to make it run and see what is going on with this class. Okay, at first Fido Brown, Fido name is printed here because we have to go from the top to the bottom, and at the end of this command Fido is printed, and after that Fido.bark method is called. Just look up here. By means of bark method, we would like to make it printed wolf, so wolf is printed. Just be careful about that. The straightforward, you have to think straightforward manner, and line by line, as if you are computer instead of you are in computer role instead of yourself, and this command will be considered and executed and interpreted, and after that this is going to be printed. Okay, let's go with our next example. I would like to give another example for dog, class dog, and here I make an assignment here. Legs variable will be assigned as four legs, and here I define an init method, self, name and color. Actually there are two parameters, name and color parameters. This structure is the same, and here I assign an object with two parameters, Fido and Brown, right? Fido and Brown, and here I would like to get it printed Fido with legs, and I would like to get it printed one more time, dog legs. Okay, let's make it run. Okay, actually I didn't mention the result will be both the same for both. That will be 4, but as you can see, when we reach this object creation, our variable Fido will be existing here. Okay, and legs will be printed. Okay, 4, and here dog instance is created with legs. This is gonna give the same result as we expected. Okay, let's see the last example. Okay, I here define a student class, and I define init method, and I've got only one parameter here, such as name. So self.name equals to name, and I here define another method here, such as say hi, and it's gonna have self parameter, and here I would like to print it two strings. In fact, one string is hi from and just look here a space, and I would like to make it concatenated before printing, and self.name, and our class definition ends here. And after that, just I have to give 2 lines, yes, and S1 equals to S1 assigned to S1 student student instance with any parameters. Okay, just make it run. Hi from Emmy, but we have not printed yet. Say hi, say one dot say s1 dot say hi. So after executing this line, this message will be printed on the screen. That's all for now, guys. Thanks for your following me with these codes. This happened to be shorter because just I hesitated to make it completed in final lessons, or just to divide it 2 sections. So just to give some hints at the end of this course. I hope you enjoyed this one. Our next Python lessons will be the last one, and at the end of the last example, I'm gonna give some hints also about programming algorithms, etc. And by now, keep in peace and enjoy the remaining hours of your day. Thanks for your watching me. Bye bye.